Data centers need to become more efficient in the speed with which new applications can be provisioned, since the pace of change of the business environment is at an all-time high. But in order to achieve this, there needs to be far more automation of processes and the formation of templates and a service catalog that permits the efficient deployment of new services and applications. But this in turn requires the ability to manage the discrete items within the data center by policy. Policies that define the performance characteristics, storage and data retention requirements, security levels and the like, but that are then picked up by the underlying systems without the need to program and reprogram the discrete systems individually. Whilst many of these changes are well understood, the gap between what an average data center looks like versus a highly transformed data center is quite considerable, and for many, the journey to an efficient hybrid cloud environment will be long and arduous. In May 2014, IDC Asia Pacific conducted a study of the levels of data center transformation within the Asia Pacific markets and managed to identify not only those that were in a highly transformed stage, as well as those that have yet to embark on any real transformation journey, but have also identified a number of key areas that need to have a sharper focus to help organizations better prepare for the steps of this transformation journey. IDC has identified a transformation journey that consists of 5 steps, which are consolidation, virtualization, automation, orchestration, and federation. Each of these key stages has discrete elements that help organizations transition from step to step, whilst providing a longer-term view of where the architecture should be heading. Stage 1 is consolidation. This includes the consolidation of physical data centers as well as the systems within the environment. Moving to larger multi-core and multi-processor systems that can offer a far better economies of scale than many small systems, and in the process help to lower the overall capex for an organization. Critical characteristics of Stage 1 include designing the facility, the physical environment of the data center to cater for energy efficient architectures, as well as to permit the necessary expansion for the life of the facility. Virtualization is the second stage and is characterized by virtualizing the underlying compute and storage systems. One of the key values of virtualization is the ability to load balance systems across the entire platform to ensure that there is minimal waste of available capacity, offloading processes that are less time sensitive to the available capacity of a larger or more mission critical system at a time when the system can easily manage the workload without impacting its core functional requirements. Automation is the third stage, and one where many organizations in the region are stumbling, due, in large part, to a lack of available information about systems and processes that have been automated. Since IT systems are notoriously unreliable unless configured in highly available and redundant architectures, the need to monitor the systems across the board is significant. And yet, as an industry, there are very few tools that offer in-depth, holistic monitoring across the different domains of application, network systems, storage, and facilities. As a result, many that are using monitoring tools have a one-dimensional view of issues as they arise, leading to lengthy delays in resolution as the source of any error or fault is slowly and painfully identified. The view of the future is that a more holistic set of tools should radically shorten the time taken to identify the root cause of any IT issue, thereby radically reducing the time to resolution. Clearly, this also requires some level of dynamic from a wide range of people across the systems and applications, as well as an open and support-friendly attitude from the software development teams. But this is not a new issue. Stage 4, the orchestration stage, is where the systems are being managed more by policies for sets or classes of applications than by individual applications. This permits deployment of a self-service portal that radically improves the time taken to provision new applications and then applies the necessary policies to the data, security, network and compute needs of the application. There is, however, a significant amount of work involved in defining the right number of relevant policies within the environment, and then being able to explain this approach to the business. The heavy lifting required during this stage will, however, provide the business with what they have been seeking: a more agile and dynamic IT that can respond to the demands of the business in a time frame the business expects. One way to ensure the business understands the value of this approach to IT is to implement some form of metering in order to either charge back or show back the costs of the IT systems to the relevant business units. Until this approach is achieved, business users will constantly expect SLAs that are over-specified for their systems, such as demanding enterprise-class storage performance and multiple nines uptime, when the application may not financially justify such demands. But without the showback data, it is not possible for the business to fully understand the ramifications of such demands they are making. Showback data ensures the business is much better equipped to make a value-based decision. The final stage of the transformation journey is federation. The IDC view of federation incorporates the concept of a hybrid cloud environment, as well as what many are talking about as a software-defined data center. Hybrid cloud simply means that the underlying infrastructure is sourced from multiple places, not all of which are on-premise and managed by the internal IT. Perhaps the best example of a hybrid solution is the concept of cloud bursting, that is, leveraging cloud computing platforms for excess capacity only as and when the internal systems cannot handle the demand. Correspondingly, the vision of the software-defined data center is one whereby the hybrid architecture can be managed, monitored and maintained by a single integrated management tool, one that can span both the internal and external systems. Currently, this view is more of a concept and not one the industry is yet delivering upon today, but it is clear that the potential for this approach would be something that would appeal to many end users. Thank you for watching this webcast. If you have any questions or comments, please contact me at the details here.